All right, good afternoon, good evening, good morning, good night, whenever it is you're watching this video. I don't know. Brought to my attention yesterday that some of my videos don't have audio. If this one does turn out to have audio, and you have one that you have watched before that did not have audio, please let me know so I can go back and redo that video. I think that they said the distance and midpoint one from last week did not work. Okay. So we're still going with our X and Y axis, our Cartesian coordinate system, and seeing what all we can do on it. Today, we're going to be doing circles on it. Okay, definition of a circle is going to be the set of all points in a plane that are a fixed distance, called the radius, from a point on the circle. Okay, so I'm going to be very vague with some of this. I'm just going to make up a point right there and put a circle. I'm not worried about counting too much on it, just to get the idea of what all this is talking about. First thing it says is that it's a fixed distance. This fixed distance, is going to be known as the radius, r. And so it doesn't matter where I go out on this circle, it should always have the same radius. From this fixed point in the center, this fixed point in the center is right here. I'll just draw an arrow. This is the center. And you're going to see me denote this center today with the letters H and K. Now, how H and K and R all relate to each other turns out to be very Pythagorean again. If you took geometry with me, we actually derived this from the Pythagorean theorem. For today, I'm just going to go ahead and give you the formula. We have two different forms that we're interested in when we're talking about a circle. The first one, the more used form, is going to be x minus h squared plus y minus k squared equals r squared. So I'm using some of these same letters that we saw over here. Notice I have the h and the k and the r in there. Okay. Now, eventually what I'm going to want to do is fill in the h and the k and the r with their actual values. They're going to be numbers. And whenever I do that, I can FOIL everything out, expand it out, however we're going to work it, and I can get it into general form. General form looks a little bit messier. It is going to be ax squared plus by squared plus cx plus dy plus e equals 0. So today what we're going to be wanting to do in this video is be able to graph circles as I have done on the right side over here, be able to get standard form from them, go from standard form to general form to standard form to the circle, every which way you can think of, okay? So I'm going to start by just making a circle over here. I'm going to use a different one to use some different values. I did this one a while ago with one of my classes. I use this point right here, okay? And we'll just come down to here, here. I'm going to do my best to draw a circle. No laughing at my circles. I do the best I can. Oh, looks like it got pushed in right here a little bit. It'll buff, it'll work. We know what's going on. All right. So first order of business, it says find the center and the radius. I can pick up the center really easily. I'm just going to come over here and count. We did the XY coordinates system not too long ago. 1, 2, 3, 4, 5. Negative 6 is how far I came in the X direction. And then I went up 2 in the Y direction. So just land at point negative 6, 2. And so the fixed distance that I attempted to do on this was 4. I tried to go 4 out in every direction except for maybe where that arrow is pointing at where it got squished a little bit. It kind of looked like my sandwich today at lunch. I guess my son might have got a hold of that or something. I don't know. So I want to put this into standard form. Okay? If you remember standard form, I'm just going to copy this from the last slide. X minus h squared plus y minus k squared is equal to r squared. And what I want to do is I want to plug in my h, my k, and my r. I'm going to do this in kind of several steps just for this first example. So I plugged in my h and k and my r. Now the way the book's going to have it, and the way I want to see it on your quizzes and tests, is I want you to go ahead and make it so this minus negative 6 right here just turns to a positive 6. still have the y minus 2 squared. I want you to go ahead and tell me that 4 squared is 16. And so this would be my standard form. One thing I want you to notice that we're going to be seeing over the next few weeks is that this -6 and +2 actually flipped around, became a +6 and -2 in my equation. Get used to that. Anytime you see something that's inside an equation, or in this case, inside parentheses, it tends to act the opposite way, okay? One thing I want to show you on this is how to find x and y coordinates, or x and y intercepts on this circle, okay? I'm going to do x-intercepts first. Whenever I find the x-intercepts, I'm finding where it's crossing the x-axis at. That means that my y values are 0. So my x-intercepts are going to be at something 0. I got to find out what that something is. Well, if I know that my y is 0, I can just plug in, let's see, x plus 6 squared. Plug in a 0 in for my y, and just solve this equation all the way down for x. So that's going to give me x plus 6 squared plus, let's see, -2 squared would be a 4 equals 16. Just working this down. We should be pros at solving this. Oh, that's square root of 12. I think that breaks down into 2 square roots of 3. Since I took the square root of both sides, I need to have my plus or minus in there. So -6 plus or minus 2 square roots of 3. That's where these x's should have landed if I would have had a proper circle drawing tool and so forth. If I was on my Mobi, I could have done a lot better with that. But that's where it would be at. Okay, so for the y-intercepts, as you can see, this thing doesn't even touch the y-axis right here. So for the y-intercepts, what I would want to do is I'd want to plug in a 0 in for my x this time, and then solve this all the way down for y. If you want to pause the video and try that, you can. I'm just going to tell you that we're not going to get any y-intercepts because it doesn't ever touch the y-axis. So if I was to work this out, I would probably get y equals something that's imaginary. And we're not worried about imaginary numbers in this case, so we would just be interested in this x-intercept up here at the top. I know a couple problems tonight that I'm assigning will have this x-intercept and y-intercept that it's asking for. We're going to solve it just like we did in the last unit. Just wanted to make it so that it did look familiar to you. All right, example 2, they don't have a picture for us. Okay, but I think we can get all of our information that we need. So I'm going to let you go ahead and read this, pause the video, and go ahead and set up your standard form first. Okay, go ahead and work that out, and then we'll come back. I hope this matches up with what you have. Make sure that you did change this +2, +8 to a -2, -8. That just helps it flow in the formula better. So I have my standard form. That's going to be one thing I'm looking for. Now the general form. Now the general form, I'm going to need to write everything out and FOIL it. I'm going to FOIL my x's together, FOIL my y's together. I would like to get to the point where we can do a binomial expansion. I don't have to worry about foiling. So let me show you how to do a binomial expansion on these squared terms up here at the top. What I can do is I can always square the first term. I can multiply these two together, -2x, and double it, and then square my last term, +4. That gives me the same thing as if I was to FOIL on this step. If you need to FOIL, please FOIL. I'm interested in getting down to the correct answer, but there is a quicker way. Once again, working it on these y's right here, I can square the first term. I can take the product of these two, -8y, and double it. And then I can square the last term. -8 times -8 is +64. As you can see, we're already a lot closer to general form just from that FOILing and expanding step. I think one more step I can have it. So I'm going to go ahead and make it so that my x squared term and my y squared terms are up front. And notice still x is coming in front of y on this general form. Next, I'm going to bring down my x term, -4x, and my y term, -16y. And remember, I'm wanting this equal to 0, so I'm going to need to subtract 36 from both sides. And so whenever I subtract 36 from both sides, I got to also factor in this 4. I do believe that gives me a 32. This is the general form. It's not used very much, but there is a need for it. So make sure we do get the practice on that this evening when we're doing the homework. Okay, so let's go back to graphing and see a couple different other ways that I can rearrange how I ask this. So this wants me to, again, find the center and radius. The center and radius is just something that kind of helps me out. If you misplot something, or if your circles look maybe worse than mine, I really hope they don't. With pencil and paper, these should look nicer. I can kind of tell what they mean for that radius to be. Well, the center on this one, remember we got to change the sign. It's going to be -1, -3. It's going to be -1, 1, 2. Oops. Oh, wrong way. 1, 2, 3. Let's go down here. -3 right here. And the radius this time, I'm going to take the square root of 11. Well, the square root of 11 does not help me get too far into this problem. So I'm going to need to go ahead and decimal that out. And 1 decimal spot is going to be enough for what we're going to be doing on this. So that would be 3.3. So what I want to do now is I'm just going to go 1, 2, 3.3. 3.3 in every direction. I'm going to do my best not to draw a diamond. No promises here. Yeah, that's about the best I've done. Still kind of looks like a lemon. It'll be okay. So I can ask you to graph a circle just from the standard form, or I can ask you to draw it from general form as well. So I'll still want the center and the radius, but it's going to be a little bit harder to find the center and radius on this one. So I do want it in that standard form that I'm used to seeing that made the last problem so much easier. And what I noticed about standard form is that all my x's come together up front. And then all my y's come together back here. And if it doesn't have an x or y, I boot it off to the other side, and it's going to become part of my radius. So I just subtracted 22 from both sides. Yes, I left that awkward space right there for a reason, because I am going to have to complete the square in order to finish this. So I took half of 10 is 5. 5 squared is 25. Let me write out what I'm doing here. I'm taking half of 6, which is 3, and then squaring it. It's 9. Now, before I added that 25 and the 9, I had an equation. I had the left side equal to the right side. It's hard for me to imagine that I can add 25 and 9 to this side and still make it so it's equal. So remember my rules on that. Addition property of equality says that if I add something to one side, I must add it to the other in order for it to stay equal. That's going to make these left sides factor really nicely into x minus 5 and x minus 5. And even this y trinomial right here will be y plus 3 and y plus 3. Kind of see our standard form coming into effect here. Let's see, 3 plus 9 is 12. I have my standard form. I'm able to grab my center and my radius, and I'll be able to graph it. You go ahead and do that. Hit pause on the video, and we'll come back and see if we match up. This one looks like I went back to my lemon drawing ways. The other side of my circle is squished, but this gets the idea across. Once again, make it look better on your paper than I'm able to do up here on my smartboard. One last example, and then we'll cut through to the homework. It says find the standard form for the equation with the circle with center -3, 1, and tangent to the y-axis. Oh, thank goodness, standard form. I don't have to worry about anything with general form on this one. So I like to go ahead and just write this in so I can just fill in my blanks as I go through. Well, I know the center is at -3, 1, 2, 3, +1. So that means I'm going to put x minus -3 or x plus 3 in this spot, and then x minus 1 in this spot. Now, it says that it's tangent to the y-axis. This doesn't have anything to do with sine, cosine, and tangent. Tangent to something means it touches, it just simply brushes up against something. in this case the y-axis. So it doesn't want me to graph, so I'm just going to kind of do a rough sketch of it, what's going on. This thing is just going to come up and just kind of just barely touch the y-axis like so, and then go off and stay on the same side. Well, I lucked out on this one because if that happens, remember that this center has to be equidistant, it has to be equidistant from all points on the edge of the circle, making it so my radius is just 3. If I square that, I can put a 9 right there. Well, suppose I'm given something that's not quite as easy. Okay, so an alternate way of working this that you might need in your homework is seeing, well, that is touching the point 0, 1, correct? And so what I could do was I could just plug in, switch colors again, a 0 in for x and a 1 in for y. And I wouldn't know what r is in this case, and I could just square it. I could just work this down, and sure enough, I still would get r squared is equal to 9, and I could just plug that answer. So either work it graphically or work it using the formula. I'm good either way, as long as we are working it correctly. Here's the homework. You got 10 problems. Now, I'd like this word problem worked on as well.